Hi, my name is Shantan Kethireddy. I'm the VP of Customer Solutions at Ocient. Thank you for attending our webinar. So today I'd like to go a little bit deeper on some of the workloads that we've been discussing in AdTech. I'm going to talk about some customer scenarios that we've seen with our DSP and SSP customers, as well as our performance TV customers. And so a lot of these cases have massive amounts of bidder log data. And so you could think about roughly a lot of these customers have about a petabyte plus of data that's generally streaming and that's already kind of downsampled to, say, 1 to 3% of the data. And as you can see on this chart, they also might be consuming win-loss data that they're analyzing alongside their bidder data. And then they might have impression data and event data that's typically coming in after the fact or late arriving data, and that data can be coming in for many days or many weeks. And a lot of this type of data, the bidder data as well as the win-loss data, is data that's being streamed in through Kafka at a very high rate, tens of thousands to hundreds of thousands of documents per second as JSON data or protobuf data. And alongside that, oftentimes we see customers that are also loading verification data of their ad placements or information about their campaign strategies, as well as their PMP deals with their deal IDs. And that data can often be changing. And so to process the inserts, updates, and deletes, they may store them in an OLTP environment, which they then cascade to the OLAP system for analysis. And so in most of these use cases, as you can imagine, these are different kind of disparate types of data, and oftentimes it's multidimensional or semi-structured data. And so customers have ETL interfaces that they stand up that are used to take the semi-structured data and then transform it into a relational format. And so they use tools such as Spark and Informatica. And to make all of this kind of palatable, right, at this type of scale, customers in the AdTech space will use downsampling and approximation techniques or sketching, again, to make the data digestible using their current modern solutions. And so modern systems that we see that are running and trying to analyze against these petabyte scale data sets, whether it's a NoSQL repository or a relational database, typically will find it challenging to do all of these types of workloads. So a forecasting workload with a lot of filtering criteria, combined with being able to do very complex join, sorting, grouping, aggregation against very large data sets. So this customer on this slide was using Redis, which was feeding data to a custom Java API for forecasting. But really, when you think about forecasting and campaign performance, you're really talking about very sophisticated queries. So as Anudith mentioned, you might be analyzing geodata and device type data, or you may be looking at the app ID or domain strings and doing string searches. Oftentimes with AdTech data, you have very large arrays. So you have very large segment ID arrays or third-party audience data sets, or you have contextual information about a website in arrays where you have hundreds of array values per row. And then another challenge with forecasting is you often have a mix of very complex filtering criteria. So you may have a mix of CNF and DNF predicates, which is a mix of ands and ors. You might have inclusion lists and exclusion lists. And then in the same query, you might be applying things like frequency capping on top of that. And so what we see in most of the cases with customers whose workloads we've worked on is that for them, in order to handle these cases today, they've kind of built this sprawl of infrastructure to handle individual cases. And so what that results in is that the people with the domain expertise, who are developing the application and who are creating innovation and generating revenue from these applications, are spending a disproportionate amount of their time focusing on managing the topology and managing these processes. And so on the next slide, we see that Ocient has taken a kind of a consolidated approach that combines capabilities into a single data platform. And this data platform, this consolidation, really drives cost reduction and a lot of efficiencies by consolidating this sprawl of infrastructure and being able to handle a lot of these workloads against a single set of data versus having copies of data throughout the ecosystem. And so what this means is, first and foremost, consolidating batch and stream loading into the platform. And so rather than having standalone ETL interfaces and Kafka interfaces, et cetera, Ocient, as a solution, as an end-to-end kind of solution and platform, has integrated the ability to stream and batch load this data into the system. And what this allows you to also do is co-locate the various sets of data that I talked about in the last slide into the same system without leveraging separate ETL tools or separate databases. So separate ETL tools to stream load the JSON or proto data into the system, a separate tool to batch load from S3 and GCS, and then multiple systems to handle the different data sets. Now, you could do that all on one platform with Ocient. And then you can also index and store the data in a way that makes querying in these multiple ways possible. And we're going to talk about that some more. But you can do all of this, these analytical type workloads using modern interfaces. And so what I mean by that is, in a single system, you can do the complex kind of filtering that you might see in forecasting, but also all of the complex types of analytics that SQL offers, so very intensive grouping, sorting, joins, and aggregations. And then on top of that, also in the same platform, doing machine learning against the data. And so one of the things that's important to point out here for AdTech customers is that ML is not just about modeling. A great deal of the time that's spent on AdTech related ML workloads is focused on data exploration and hypothesis analysis. And so this deep analysis, oftentimes today, is done by taking a small copy of the data to some, a standalone system or laptop, and then doing some, basic machine learning analysis or machine learning analysis against a small set of data. And so in this case, what we're allowing you to do is to do this analysis against the very kind of ground truth data on the system, or create a kind of a derived source, but on the same system, so that you could do a great deal of exploration analysis against the data. You could repopulate that data with other data from other geos or other device types or other third-party audience profiles and things like that. And then you can do the modeling either intra-database, and scoring intra-database, or you can alternatively reference those derived sources that are in Ocient through things like Jupyter Notebooks or through Spark, through various drivers. And so on this next slide, we see that this consolidated platform can also service many different orthogonal applications. And so it's very important to point out that you can't just throw a bunch of data and a bunch of workloads on a single system and expect it to work. A lot of these workloads have different characteristics in terms of the amount of data that they analyze, but also in their service level objectives, their SLOs. And so you might have cases where campaign forecasting is critical to meet SLOs that are in the 5-second range. And so you effectively want to create a situation where those queries get the highest priority and that other workloads that are running concurrently will not affect those service level objectives. But then At the same time, you might want to run very complex batch analytics. So you might want to run bid shading analysis against a huge amount of data in order to look at first price auction, second price auction dynamics, and do a bunch of grouping and aggregation around that to optimize a bidding strategy. And in that case, the SLOs might not be mission critical because it's more of a batch style analysis. And so you may choose a kind of a lower service class. So again, pointing out that to do these types of workloads where you're doing things like campaign forecasting and bid shading in the same platform, these are things that you can kind of co-locate the data in the same platform using Kafka and being able to load the data either through file loading or stream loading, and then co-locate the data on the same platform, but then also use Ocient's sophisticated workload management capabilities so that you can run a lot of these orthogonal workloads concurrently in the same environment versus what a lot of customers are doing today where they have an ETL tool and then they have separate platforms where they may have a NoSQL database to get data in for forecasting and fast indexing, and then they might have some other environment for deal troubleshooting and bid shading and things like that. So again, high priority workloads, tight SLOs, can be run as a high service class, and then you can have other workloads running at various service classes to establish the best SLOs for the objective. And so at the bottom here, you see that in terms of the benefits. So again, querying petabytes of data in interactive time with with SQL. And again, we're going to talk about how that's accomplished on the next slide. But AdTech related workloads, kind of almost by definition, are hyperscale data sets, and they are also multidimensional data sets. So while you may have hundreds of billions of rows of raw bidder data, for each of those rows, you might have hundreds of array values for third-party audience data sets or segment IDs, and in those cases, the size of the data gets very significant very quickly. Of course, faster time to market, again, by having a single platform with an integrated ETL capability and the ability to put or co-locate data on the same platform will drive faster time to market. And so ultimately, not having to manage multiple kind of platforms and to run the analytics, whether it's SQL or ML on the same platform, really increases speed to market. And that includes new innovative projects, right? New revenue generating projects. In terms of simplified operations, all of this is available, and all of our customers in AdTech today are running as a fully managed service. And again, a single platform that's available in Ocient Cloud, in GCP, in AWS, on-prem, or a hybrid approach across those environments. And then finally is cost. Of course, to go on this journey of replatforming from these incumbent environments, one of the critical factors is, can we drive efficiencies as well as the cost savings? And in these cases, by consolidating these environments, we're often seeing over 50% TCO savings and ROIs expressed in less than a year. And also the ability, again, to eliminate costly streaming ETL environments, as well as separate environments that are being used for dashboarding and separate environments that are being used for forecasting, et cetera, and being able to do those on a single environment running on commodity hardware. And so lastly, I'm going to go through some of the Ocient-specific optimizations that improve performance in AdTech. So in the first silo, you see complex data types. And again, oftentimes, much of this data is multidimensional in nature. And then to flatten the data or to essentially multiplex the data across high cardinality values applied to each individual value of a array, for example, will categorically expand the data to sizes that modern day solutions cannot do. So it's extremely important to be able to handle data and to store data in the multidimensional format and to be able to analyze those data sets in that format. And so being able to store data as tuples or arrays, again, says third-party audience data or segment data or other user IDs. This is very important to support this multidimensional data set, especially for these high cardinality columns. And then support predicates against those multidimensional data sets, so contains and like and similar to and so on. In the next silo, we see efficient indexing. And so again, with forecasting and some of these other deal troubleshooting is another example where you're looking at a lot of very complex filtering criteria. And you may be doing multiple kind of queries in one, where you might be doing frequency capping as well as kind of a top-level count. But you're applying all of these sophisticated mix of ands and ors, predicates against arrays. And so it's important to have a solution that has a indexing strategy that allows you to create indexes on both the fixed length and variable length column data, as well as the multidimensional data. And then to do things that allow you to compress the data through GDC or global dictionary compression or Z-standard or LZ4 type compression algorithms. The next silo, we see the ability to handle high cardinality data. So it's not just integer data, for example. Oftentimes we have string data. So for example, being able to effectively query domain names or very high cardinality data such as UUID or user IDs. And so these are, again, things that, because they're high cardinality, typically you wouldn't create an index against them, but being able to run things like n-gram indexes against string data and being able to do that very effectively is absolutely critical in these workloads. And so the last two silos, extreme I/O performance, and again, this data is very voluminous or hyperscale in nature, and so any database that is co-locating a lot of these data sets and running concurrent orthogonal workloads has kind of one of the largest tasks is to eliminate I/O as fast as possible. And so with Ocient, we've created a very rich set of capabilities at the I/O layer, right at the drives where the data is stored, where number one, Ocient leverages NVMe drives that are capable of pushing almost 1 million 4K read IOs per second, per drive. And then also to be able to do eliminate data, and what I mean by that is apply filtering criteria like the time ranges, as well as apply filtering criteria against clustering keys to eliminate things based on, like, if you want to look at a specific geo or a set of geos, if you want to have a mix of inclusion criteria as well as exclusion criteria. A lot of those things can be applied right in the I/O layer in Ocient, so you can prevent even the I/O of data across the system. And then you can use more probabilistic features to reduce I/O, such as some of the plan swarm optimization capabilities that exist within Ocient. And then finally, as we talked about, being able to do this high throughput loading and extract of data is especially critical in making the consolidation and cost reduction case. But it's also extremely important because as you load this data into a relational database, you also want to be able to transform the data and apply user-defined transformations using James Path logic, for example, and do some really complex transformation of the data to make the analysis of that data more performant. The last thing I want to say, and one thing that's not captured here is, it's not enough just to have a database that sits on top of solid state drives and push I/O quickly. You also have to have a system for these workloads that's capable of consuming that amount of data and process that amount of data, and then to do that across all of the concurrently running queries. And so as the data is pushed from the kind of IO'd or pushed from the drives, it's very important to be able to have a system that's built to handle the massive amount of I/O. So you can't just stick a database on top of NVMe and expect it to run fast when you're producing trillions and trillions of records in flight at a given point in time. You need to have a database that's capable of handling that type of workload in two ways. Number one, to basically not do things like locking in favor of queuing, and to have high-speed interconnects, so 100 gigabit per second network capability throughout the database to handle these types of queries. But then, again, having a rich workload management capability is extremely important. So being able to segment different workloads by service class based on service level objectives is extremely important in order to be able to handle the different types of workloads that you would see against the similar set of data in AdTech.